Okay, so in this on these problems, you're graphing these exponential functions. So you're graphing this not by using a t-table. So they want you to use this by using transformations. So if I'm going to do this by transformations, then I have to consider what the parent function is, and then use a parent function to get to this one. Okay, so remember the parent function. So I'm going to go ahead and rewrite g of x. So here's g of x. Okay, so g of x is 3 to the x minus 2. Okay, 3 to the x minus 2. So the parent function, remember, is the base. Remember, these are exponential, so we're talking about the parent function of exponential function. And you got to use a different name. So this is g of x, and we're going to call this f of x. So the parent function we'll call f of x, which is the base, which is 3 here, always raised to the x power. So it's just to the x power. So the base raised to the x power. So that's your parent function. So in part A, your parent function, you're going to say f of x equal 3 to the x. So 3 to the x. Once you get your parent function, let's go ahead and graph this. So let's go ahead and graph the parent function. Now, remember, these are exponential functions. These are exponential functions. So exponential functions have a horizontal asymptote. So since you don't see a number on this side, a constant, that's understood to be y equals 0. So your horizontal asymptote is y equals 0, which is the x-axis. So I'm going to go ahead and draw my horizontal asymptote. That's just right here. All right, and then I'm just going to go ahead and plot a few points on the parent function. Now I'm using a t-table here, but I need to use, to get to this one, I need to use transformations. But I'm going to use a t-table for this one. So remember, the domain's all real numbers. So a exponential function will always have a y-intercept. So let's go ahead and find it. So to find the y-intercept, you let x be 0. If x is 0, I get y equal 3 to the 0, which is 1. If x is 1, I get y equal 3 to the first, which is 3. If x is 2, I get y equal 3 squared, which is 9. All right, and so I'm going to just go ahead and plot those points. So 0, 1 is here. 1, 3 is here. And then 2, 9 is here. And so I'm just going to go ahead and graph this. So here's my exponential function. And so this is f of x, which equals 3 to the x. So that's my parent function. Now remember, for this particular case right here, for these two problems, when we're talking about transformations, we're only looking at translations, whether it's a vertical translation or horizontal translation. So that's what these two problems involve. That kind of transformation, a vertical translation or a horizontal translation. All right, now remember, the vertical translation is the easy one to remember. That's an easy one. So you would have a vertical translation. If you were doing this to your parent function. So this is my parent function, b to the x. It will be a vertical translation. Remember, this is kind of review for this part. Vertical translation, if your function g of x was your parent function and you're adding a number, and I'm going to put plus c for right now. You're adding a number, so the number's on the outside. And remember, if c is positive, you're translating up c units. So you'll move b to the x up c units. If c were negative, remember, if c is negative, this is b to the x minus c. If c is negative, then you'd translate vertically down. So you'd move b to the x down c units. Okay, that's the easy kind. Now that's not what you see here though. See, that's not minus 2 on the outside. Okay, so that's not a vertical translation. This is a horizontal translation. The horizontal translation is a more difficult one for students. So let's talk about horizontal translation. So the horizontal translation occurs when, see, if you look at your parent function right here, b to the x, a horizontal translation occurs if your exponent also has a number with it, like x minus 2, x plus 2, something like that. That's horizontal, which is what we have here. So horizontal translation, so this is your parent function, f of x equal b to the x, then you would get a horizontal translation if your function you want to graph was this, b to the x plus c. Now remember, for that one, it's counterintuitive. So remember here for the vertical, if c was positive, you went up. If c was negative, you went down. That kind of makes sense. Well, for horizontal, remember, it's just the opposite of what you would think. So if c is positive, you move to the left. C units. If c is negative, you move to the right c units. Okay? All right, so if I look at this right here, I can think of this as x plus a negative 2. All right, so x minus 2. So think counterintuitive. So think the opposite of this. All right, so the opposite of negative 2 is a positive 2. So I'm going to move to the right 2 units. So that's what you're going to do here. So for our example, so this will be a horizontal translation. And basically you're gonna take the parent function, which is f of x equal 3 to the x, and you're gonna shift it horizontally to the right, counterintuitive, to the right 2 units. Okay? So if you look back at this right here now, so to obtain the graph of g of x, to get this graph right here, you're gonna need to translate the parent function f of x, which is 3 to the x, right here. So f of x, how many units to which side? So it'll be 2 units to the right. That's what you're right here. So 2 units to the right. Okay? Now here's how you do this on your graph now. And this is what you got to show. So every point, see those 3 points? Just move it 2 units to the right. Now notice the the horizontal asymptote doesn't change. It still stays here. Which kind of makes sense, because if you look at your function g of x, which is 3 to the x minus 2, that number on the outside is plus 0. So it's still, the horizontal asymptote is still y equals 0. All right, but basically all you're doing though is just moving the graph 2 units to the right. So look what I'm doing. 1, 2. 1, 2. 1, 2. And now just graph it and you're done. Just do the best you can. And so this is the graph. So that's the graph of g of x, which equals 3 to the x minus 2. Okay? All right, now let's get the next one. So now this time you have this. You have g of x, which equals 3 to the x minus 5. Now notice that the constant's on the outside. So that's a vertical translation. And that's the easy kind. So basically, you're going to take the parent function, which is still 3 to the x, and you're going to shift it, since c is negative, you're going to shift 3 to the x down 5 units. So everything will be moving down 5 units. Even, see, this is your parent function right here. Look at your parent function. Even the horizontal asymptote. Everything is moved down. So to obtain the graph of g of x, which is this right here, we need to translate the parent function, which is this, 5 units, and I said I should say 5 units down. 5 units down. Okay? All right. So 5 units, and I guess I should have put space here, and I should have did this. So you would say 5 units to the right, and then here you would say 5 units down. All right. So now that's going to look like this. So we graph the parent function. So everything will be moving down 5 units. So 1, 2, 3, 4, 5. So here's my horizontal asymptote. And then take these 3 points and move it down 5 units. Every point in this graph is moved down 5 units. So you know 3 of them, move them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to go ahead and use a different color because I have too many graphs on here. So let's go ahead and use red. So here's the graph of g of x in this case. Do the best you can with drawing this. So this right here is g of x equal 3 to the x minus 5. Okay? All right, so that's going to take care of this these 2 problems using transformations.